Good day, students. Today we're going to look at the solution to your turn 2, part of your chi-square distribution notes. So let's get right to it. From the latest Qatar census, it was determined that the distribution of ages were as follows. So the age groups in the first column, percentage in the second. Under 5 years of age, 14% of the population under 5, between 5 and 18, 23%, and so on. And they took a sample of 500 people, random sample of 500 people, and the observed ages were as follows. Under 5, there were 65 people under 5. Between 5 and 18, 108 people, to a total of 500. Can we conclude that the observed ages are the same as the census information? Using a level of significance of 1%, using a goodness of fit test, test this hypothesis. Okay, so let's get some more room on the screen here. Now you notice I've rearranged the table and extended it and moved the observed into the first table and left the column for the expected, because this, in goodness of fit test, that's what we're doing, to see if the observed data fits in to what's expected. Okay, goodness of fit. Now, so when you have one with percentages, your observed or expected values, I should say, are not going to be all equal. Okay, so this is an example of unequal expected values. Now, how do you calculate each one? Well, according to the census, under 5, we'll do the first one, is 14%. Now, in our total sample, there's 500. So 14% of 500 should be the expected value for under 5. So 14% of 500 that were sampled, so that's 0.14 times 500. Okay, which is equal to 70. So 70 is the expected number for under 5. Now, so just take each percent and multiply by the total observed. Okay, so 0.23 is the next one. I'll just change it to a decimal, times 500. And that gives us 115, okay, which goes here. 0.11 times 500. Okay, for 55, oops, 55, 37 times 500, and we get 185, and 15% times 500. Okay, and that's 75. Now you should always double check and make sure that the observed total equals the expected total. I'm just going to run a double check here. 70 plus 115 plus 55 plus 185 plus 75. Let's see what we get there. It is indeed 500. Okay, so now let's go through the process. You know the process is the 5-step process, so let's go at that. Step 1, of course, is state your null and alternate hypothesis. Okay, what is HO in this case? Well, HO is exactly what we're saying, that the observed ages are the same as the census information. Look right there, are the same as the census information. Okay, so the observed ages are the same as the census information. Okay. Now, what's the alternate to this? Okay, well, the alternate is the observed ages are not the same. Not the same as the census info. Okay, so that's not too bad to come up with the null hypothesis and the alternate hypothesis. Now, step 2 of this 5-step process, you should all be aware, of course, is choose a level of significance that's appropriate. Well, we don't even have to worry about choosing because it's given to us. We're told to choose alpha to be 0.01. Okay, step 3 is choose the correct statistic. In this case, we're going to run the chi-square goodness of fit, GOF test. Remember, when observed versus expected like this, we're seeing if the observed fits in to what's expected. So it's called the goodness of fit test. And number 4, here's where we actually get into the work. chi-square critical value. Now, notice in the chart I have up here, the chi-square critical value. Okay, I got it marked right here. This is the value that divides the region into reject and do not reject, right? Of course, this region up here, alpha, is where we reject the null hypothesis, right? So anything greater than the chi-square critical value we'll reject. And anything less, we're not going to reject the null hypothesis. So it's do not reject the null in this area. That's the region. Now, notice, of course, that chi-square distribution is a positive skew. So this is always a right-tailed test. So we just say it's always greater than when we test the critical value, right? Now, how do we find that critical value? Well, we actually find it from a table. Okay. Now, before we do that, we need degrees of freedom, of course. Degrees of freedom is the number of categories k minus 1. And you can see right here, the number of categories looks to be 5. K equals 5. Yes, 5 it is. So 5 minus 1, the degrees of freedom is 4. Now, going to your table, so let me just bring up the table here. Okay, now you see your table. Now, we're looking for degrees of freedom of 4 with a significance level of 0.01. Okay, here's alpha, here's 0.01. And 4 degrees of freedom is right here, so our value is 13.277. Okay, see how I got that? 13.277. So chi-square critical value is 13.277. That's this value right here, right? 13.277. So anything greater than that will reject. Anything less than that, not reject. So that's our decision rule. So the decision rule, okay, and this is the second part to step 4. Your decision rule is if chi-square test, which we do in step 5, is greater than 13.277, then reject HO and accept H1. Okay. Oops, accept reject HO in there, accept the alternate, H1. Now, if you're just using the p-value test, if you're just using p-value, then your decision rule is very similar, except we should know it by now. If p is less than alpha, which is 0.01, then reject HO and accept H1. Okay? So there's your decision rules, either whichever method you're using, if you're just using the p-value or the chi-square critical value. Now step 5, we know what we do there. We find the chi-square test value. And this is where we use the calculator versus using the formula to find this value. Okay, now in order to do this, of course, we need to put anything in the observed into list 1 and expected into list 2. Now, how do you do that? Again, stat, edit. So stat, edit, and you're right into the list. Now notice I've already put the data in, but I'm going to double check it. 65, 70, 108, 115, 68. Always double check your entry, and it looks like I have it correct. Okay, next is stat. Go to test, and scroll up or down till you come to goodness of fit, D:, chi-square goodness of fit test. Enter. Now the first thing it's going to, calculator's asking you, do you have the data in list 1? The observed data, yes, in list 1. Expected in list 2. Enter your degrees of freedom. It is 4, so I don't have to change that. And calculate. Now your chi-square test value comes out to be 17.23. Now 17.23, if you look at your chart, that's definitely greater than 13.277. So it's in what region? It's in the reject region, because 17 is up here somewhere, right? So therefore we can say if it's in the reject region, therefore reject HO and accept H1. Or yeah, accept H1. Now if you're using the p-value, that also comes from the calculator. Still have to choose the right test to get the right, enter the right data to get this p-value. The p-value is 0.0017. Now that's definitely less than alpha, which is 0.01. So the same conclusion. Reject HO and accept H1. Now, what is H1? You should write that out in words. H1 suggests that the data suggests, or it is reasonable to say, the observed ages are not the same as the census information. Okay, so there's your conclusion. Okay, that's a complete solution to your turn 2. Hopefully that helps. Bye for now.